Look around you right now. Everything you see, everyone you've ever known, every story that's ever mattered in human history. It all happened within a few kilometers of where you are sitting. In the next 45 minutes, we're going to travel 13.8 billion light years from your current position. We will witness worlds that would kill you instantly, pass through regions where a single step takes 1,000 years, and reach places where entire galaxies look like specks of dust. By the end, you will never look at the night sky the same way again. I'm John, and this is Galactic Gateway, where we explore the universe's most incredible mysteries. Are you ready for the journey of a lifetime? Let's begin. For the first time in your life, you see Earth's true shape. Not flat, but curved, like a marble wrapped in the thinnest possible layer of gauze. That gauze? It's our atmosphere. The only thing standing between us and the vacuum that wants to kill us. Let me put this in perspective for you. Earth's atmosphere, this protective blanket that makes all life possible, is only about 100 kilometers thick. If Earth were an apple, the atmosphere would be thinner than the apple's skin, and we're about to leave it behind. Watch what happens to the familiar worlds as we climb. At just 10 kilometers up, typical cruising altitude for commercial aircraft, you can still see individual buildings, cars moving like ants on highways, the geometric patterns of farmland caved into the landscape. But keep going. At 100 kilometers, the atmosphere starts to thin dramatically. The sky turns from blue to black as there aren't enough air molecules left to scatter sunlight. This is officially where space begins, the Kármán line. At 400 kilometers, where the International Space Station orbits, something magical happens. The Sahara Desert, the vast ocean of sand that spans countries, now looks like spilled amber across North Africa. The Amazon rainforest, which covers an area larger than Australia, becomes an emerald smudge threading through South America. Those cities that felt so massive when you lived them, New York, London, Tokyo, they're just bright dots, like glowing circuits in the dark. The lights that seemed so important, so permanent from the ground, are barely visible sparkles from up here. At 1,000 kilometers up, entire countries start looking like abstract art. The eastern seaboard of North America, home to 100 million people, becomes a single curved line. The Mediterranean Sea, cradle of Western civilization, glints like a metallic mirror, so bright it hurts to look at directly. Keep going. At 10,000 kilometers, you can see Earth's entire day side at once. Weather systems that dominate news cycles, hurricanes that shut down entire regions, storm fronts that affect millions of people. They look like gentle swirls of cotton against blue marble. Here's something that will blow your mind. As we climb higher, Earth's protective layers become visible as distinct shells. The troposphere, where all our weather happens, appears as a turbulent band at the bottom. Above it, the stratosphere, forms a thin, hazy layer. This is where the ozone layer sits, invisibly protecting us from deadly solar radiation. Higher still, the thermosphere glows faintly as it bleeds into space. This is where aurora happen. The northern and southern lights that we think of as magical displays are actually Earth's magnetic field wrestling with particles from the sun. Here's something to think about. Every breath you've ever taken, every breath any human has ever taken, happened within that bottom layer, the troposphere. It's only about 12 kilometers thick. Mount Everest barely pokes into it. Commercial jets fly at the very top of it. And we've already left it far behind. Astronauts have a name for what you're feeling right now. They call it the overview effect. It's the moment when your brain finally understands that every war, every love story, every scientific discovery, every moment of human drama happened on that single sphere floating in infinite black. Edgar Mitchell, who walked on the moon during Apollo 14, described it this way. You develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. By 30,000 kilometers out, about twice the diameter of Earth itself, our planet shrinks to the size of a coin held at arm's length. Cloud swirls that once covered entire countries now appear as faint brushstrokes on the blue enamel. You can see the atmospheric layers as sharp outlines, like looking at a cross-section in a science textbook. This is us from 6 billion kilometers away, the famous pale blue dot photograph taken by Voyager 1. Carl Sagan wrote about this image: our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. From here, Earth isn't even a pixel. It's smaller than the grain of sand held at arm's length. All of human history compressed into a pale blue dot suspended in a sunbeam. But here's what's beautiful and terrifying. We're still just getting started. The space between Earth and the Moon, 384,000 kilometers, is so vast you could fit every planet in our solar system in that gap with room to spare. And the Moon? It's still practically next door compared to where we're going. Before we continue, I want you to pause this video for just 5 seconds and look outside. Look at the sky and try to imagine that in a few minutes, we'll be looking back at your entire planet from farther than most humans have ever dreamed of traveling. Ready? The Moon is calling and is about to show us what an alien world really looks like. This is what an alien world actually looks like. Not the green-skinned fantasy aliens from movies. This is alien in its truest sense. A place where the rules of Earth simply do not apply. The first thing that hits you above the Moon is the silence. Absolute, perfect silence. On Earth, even in the quietest places, there's always something. Wind rustling leaves, distant traffic, your own heartbeat. Here, there's nothing. Sound cannot travel through vacuum. You could detonate a nuclear bomb on the lunar surface and hear nothing but the vibration through your feet. The second thing you notice is the lightning. On Earth, our atmosphere scatters sunlight, creating gentle transitions between light and shadow. Here, on the Moon, there's no atmosphere to soften anything. Step into sunlight and you're hit with raw solar radiation. Temperatures reaching 127 degrees Celsius, hot enough to boil water. Step into shadow and you plunge instantly into darkness, so complete you can't see your own hand, with temperatures dropping to minus 173 degrees Celsius, cold enough to freeze nitrogen solid. Every crater you see is a scar from cosmic violence. The Moon's face is a record of our solar system's brutal adolescence. 4.5 billion years ago, this region of space was likely a shooting gallery. Asteroids, comets, and planetary debris scream through the vacuum at speeds that would vaporize cities. That massive crater dominating the lunar horizon? That's the South Pole Aitken Basin, 2,500 kilometers across and 13 kilometers deep. The impact that created it was so powerful it nearly shattered the Moon. If a similar object hit Earth today, it would trigger mass extinction events that would make the dinosaur-killing asteroid look like a firecracker. Here's what's incredible though. Some of these impacts happened when life on Earth was just beginning to figure out photosynthesis. While primitive bacteria were slowly filling our atmosphere with oxygen, the Moon was being pummeled by mountain-sized rocks traveling at 20 kilometers per second. The dark patches scattered across the surface, called maria or seas by early astronomers who thought they might be actual oceans, are ancient lava floods from where the Moon's heart still beat with molten rock. These aren't small lava flows like you'd see from a volcano on Earth. We're talking about lava plains the size of Texas, formed when asteroids punched holes so deep they cracked the Moon's crust and let the interior bleed out. Now here's something that should give you the chills. Those footprints left by Apollo's astronauts 50 years ago, they look exactly the same today. Every boot print, every rover track, every piece of equipment left behind. It's all perfectly reserved. On Earth, Wind and rain would erase those marks within months. Here, they could last 10 million years. The moon is a museum of its own history, preserving every impact, every geological event in perfect detail, because there's no weather to wash it away. The surface you're walking on isn't soil like you'd find on Earth. It's a regolith, a fine, powdery dust created by billions of years of meteorite impacts, grinding solid rock into particles smaller than talcum powder. This dust is incredibly clingy, because it has no moisture to bind it, no wind to round its edges. Each particle is razor sharp and electrostatically charged. Apollo astronauts discovered that this dust stuck to everything: their suits, their equipment, even their lungs when they brought it inside their spacecraft. It's like walking through ground glass that wants to coat every surface it touches. Quick question: how do you think the moon formed? Seriously, think about it. The answer is more violent than you'd ever expect, and it explains why the moon is so different from Earth. About 4.5 billion years ago, when Earth was still a molten hellscape, a Mars-sized object, scientists call it Theia, slammed into our planet with such force that it ejected enough material to build an entire world. The moon isn't just Earth's companion. It is literally made from our pieces of our planet, thrown into space by the most catastrophic collision in our solar system's history. This explains why the moon has such a small core compared to its size, why it has the same oxygen isotope ratios as Earth, and why it's been gradually moving away from us since its formation. When the moon first formed, it was only 20,000 kilometers away. So close, it would have filled half the sky and created tides hundreds of meters high. But perhaps the most profound thing about standing on the moon is the view of home. Frank Borman, Jim Lovell, and William Ondas were the first humans to see this sight during Apollo 8. Earth rising over the lunar horizon, like a blue marble against infinite black. Ondas later said, "We came all this way to explore the moon, and the most important thing is that we discovered the Earth." That photograph, Earthrise, became one of the most influential environmental images ever taken, showing our planet as a fragile oasis in an otherwise hostile cosmos. And here's something most people don't realize. The moon is tidally locked to Earth, meaning the same side always faces us. But that means there's an entire hemisphere, the far side of the moon, that no human saw until the space age. The far side looks dramatically different. It's more heavily cratered because it lacks the large maria that smooth out the near side. It's been called the dark side of the moon, though that's a misnomer. It gets just as much sunlight as the side we see. It's dark to us because we never saw it until our spacecraft ventured behind the moon. As alien as the moon feels, it's practically next door compared to where we're going next. The moon orbits at an average distance of 384,000 kilometers from Earth. Our next destination is over 1.4 billion kilometers away, almost 4,000 times farther. That tiny point of light ahead, it's about to become the most beautiful thing you've ever seen. A world so spectacular, it doesn't seem real, surrounded by an impossibility that shouldn't exist, according to everything we thought we knew about gravity and orbital mechanics. Get ready for Saturn. This shouldn't exist. What you're looking at defies everything your brain thinks it knows about objects behave in space. Those rings, they're not solid. They're not even connected. They're billions, literally billions of individual ice chunks, each one orbiting Saturn independently at its own speed, following its own precise gravitational dance. Let me give you some numbers that will break your brain. Saturn's rings stretch for 280,000 kilometers from edge to edge. That's almost the distance from Earth to Moon. But here's the impossible part. The entire ring system is only about 10 meters thick in most places. If Saturn were the size of a basketball, the rings would be thinner than a sheet of paper. Imagine trying to build something like this, a structure nearly 300,000 kilometers across, but only 10 meters thick. made of billions of independent pieces, all orbiting in perfect harmony. It's like having every grain of sand on a beach follow its own individual orbit, while somehow maintaining the shape of a giant disk. The particles themselves range from specks of dust smaller than snowflakes to boulders the size of houses. Most are chunks of nearly pure water ice, sparkling like diamonds in the sunlight. Some certain traces of rocky material, debris from ancient moons that wandered too close to Saturn and were torn apart by the tidal forces. But here's where it gets really weird. These rings aren't static, they vibrate. Storms in Saturn's atmosphere, thousands of kilometers below, create pressure waves that ripple through the ring particles like sound waves through water. The ring literally danced to the rhythm of Saturn's weather. NASA's Cassini spacecraft spent 13 years studying these rings and discovered something extraordinary. They make music. When Cassini translated the radio emissions from the rings into audio frequencies, they sound like a cosmic orchestra. Each ring system has its own pitch, its own rhythm, created by the electromagnetic interactions between billions of ice particles. And you see those gaps in those rings? They're not random. Tiny moons, some only 35 kilometers across, act like cosmic shepherds, sweeping out lanes and keeping billions of ring particles in perfect formation. Take the Encke Gap, a 325 kilometer wide clearing in the A ring. It's maintained by a small moon called Pan, which is only 35 kilometers across. Pan literally plows through the ring material, its gravity clearing a path and keeping the gap open. But here's what's beautiful about it. Pan's gravity also creates waves at the gap's edges, like the wake of a boat moving through water. Except these waves are made of ice particles and stretch for thousands of kilometers. The more closely scientists looked at these rings, the more complex they became. There are dark radial spokes that appear and disappear like ghostly fingers reaching across the rings. There are braided sections where ring material seems to weave in and out of itself. There are tiny moons embedded within the rings, creating wakes and disturbances that look like cosmic art. The F ring is particularly bizarre. It's held together by two small shepherd moons, Prometheus and Pandora, which gravitationally sculpted into knots and braids that constantly change shape. Sometimes the rings look like a twisted rope, sometimes like a series of connected loops. It's like watching gravitational choreography in slow motion. But here's something that should make you feel a little sad, and also incredibly lucky. The rings won't last forever. In fact, by cosmic standards, they're teenagers. Saturn is about 4.6 billion years old, but the rings are only about 100 million years old. When the dinosaurs were ruling Earth, when T-Rex was hunting and Pterosaurus was soaring through the ancient skies, Saturn was just a plain old gas giant with no rings at all. The spectacular sight we're witnessing didn't exist during most of Earth's history. What's happening is this. Micrometeorite impacts are slowly grinding the ring particles smaller and smaller. Solar radiation and Saturn's magnetic field gradually change their orbits. Some material rains down into Saturn's atmosphere in a slow but steady spiral. Scientists estimate that within another 300 million years, tomorrow in cosmic terms, the rings will fade entirely. We're living at the exact moment in cosmic history when Saturn looks like this. What are the odds? But Saturn's rings aren't the only impossible thing about this system. The planet has 146 known moons, and some of them are more alien than anything science fiction has imagined. Enceladus, a small icy moon only 500 kilometers across, has a subsurface ocean that might harbor life. It shoots geysers of water ice and organic compounds from its south pole, materials that come from an ocean that's been liquid for possibly billions of years, heated by tidal forces as the moon flexes in Saturn's gravity. Titan, Saturn's largest moon, is bigger than Mercury and has a thick atmosphere of lakes of liquid methane and ethane. It's the only place in the solar system besides Earth where we've found stable liquid on the surface. But instead of water, it rains methane. Instead of rocks, the shorelines are made of water ice as hard as granite. It's like Earth's alien twin, following similar patterns but with completely different chemistry. When Voyager 1 first approached Saturn in 1980, scientists expected to find maybe a few simple rings. Instead, they discovered thousands of individual ringlets, each with its own characteristics. The complexity was overwhelming. Cassini, which arrived in 2004, spent over a decade trying to understand just the basics of how this system works. Even now, after decades of study, Saturn's rings remain one of the most beautiful mysteries in the solar system. We understand some of the physics, how gravity and orbital mechanics create and maintain the structure, but the rings still surprise us with new behaviors and formations that challenge our understanding. From Earth, Saturn's rings sometimes appear to vanish entirely when we see the edge on. This happens every 15 years, as Saturn orbits the Sun. When Galileo first observed Saturn through its primitive telescope in 1610, he saw what looked like handles on either side of the planet. When he looked again a few years later, the handles had disappeared. He was seeing the rings edge on and didn't have the resolution to understand what he was looking at. It wasn't until 1695 that Christian Huygens realized Saturn was surrounded by a thin flat ring, nowhere touching, inclined to the ecliptic. Even then, it took centuries to understand that the rings weren't solid. As incredible as Saturn is, with its impossible rings and alien moons, we're about to enter a region where sunlight becomes just a bright star, where objects take centuries to complete a single orbit, and where we'll find worlds that might hide oceans beneath crusts of frozen methane. We're leaving the realm of familiar planets and entering the frontier, a place where our solar system's most ancient secrets are preserved in deep freeze, waiting to tell us stories about how everything began. Out here, everything changes. The sun, which has dominated our sky for the entire journey so far, becomes just another star. Brighter than the rest, but no longer the overwhelming presence it was in the inner solar system. If you were standing on Pluto right now, high noon would feel like a deep twilight on Earth. The sunlight reaching you would be 1,600 times fainter than what you're used to. It would take 5.5 hours for that light to travel from the sun to reach you, meaning you're seeing the sun as it was 5.5 hours ago. This is the Kuiper Belt, our solar system's attic filled with leftover pieces from when the planets formed 4.6 billion years ago. These aren't failed planets, they're pristine remnants from the solar system's birth, preserved in conditions so cold that the time essentially stopped for them. The scale out here is almost incomprehensible. Objects are separated by millions of kilometers. If you were on one Kuiper Belt object and looked for the nearest neighbor, it would appear as faint as a star, impossibly distant. The popular image of asteroid belts as crowded obstacle courses come from movies, not reality. Out here, space is truly empty. Most Kuiper Belt objects are dark, reddish brown, coated with organic compounds that have been slowly modified by cosmic radiation over billions of years. They're like chemical time capsules, preserving the original materials that formed the solar system before the giant planet swept most of it away. In 2006, NASA launched New Horizons on a 9-year journey to reach Pluto and the Kuiper Belt. The spacecraft traveled 5 billion kilometers using Jupiter's gravity to accelerate to over 58,000 kilometers per hour. Even at that incredible speed, it nearly took a decade to reach its destination. When New Horizons finally reached Pluto in 2015, scientists expected to find a dead, cratered ice ball, a cosmic fossil with no geological activity for billions of years. Instead, they discovered something that revolutionized our understanding of small worlds. Pluto is alive. That heart-shaped feature dominating Pluto's face is called Tombaugh Regio, named after Clyde Tombaugh, who discovered Pluto in 1930. The left lobe of its heart is a vast plain called Sputnik Platinia, a basin filled with nitrogen ice that flows like a glacier. But these aren't water glaciers like you find on Earth. This is solid nitrogen, frozen at temperatures of minus 230 degrees Celsius. So cold that nitrogen, a gas that makes up 87% of Earth's atmosphere, exists as flowing ice. The nitrogen glaciers on Pluto move at speeds of centimeters per year, reshaping the landscape through geological processes we never expected to find in such a small, distant world. The mountains of Pluto are made of water ice, but at these temperatures, water ice is as hard as granite. Some peaks rise 3,500 meters above the surrounding plains, comparable to the Rocky Mountains on Earth. These mountains are probably less than 100 million years old, which in geological terms means they formed yesterday. How is this possible on a world so small and cold? The answer lies in Pluto's interior. Radioactive decay of elements like uranium, thorium, and potassium generates heat deep underground. This heat drives geological processes that keep parts of Pluto active even today. Pluto even has weather. It has a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. As Pluto follows its 248-year elliptical orbit, the atmosphere expands and contracts dramatically. When Pluto is closest to the Sun, the atmosphere becomes more substantial. When it moves farther away, the atmosphere literally freezes and falls like snow. We are witnessing Pluto during a time when its atmosphere is relatively thick. By 2030, as Pluto continues its orbit away from the Sun, much of its atmosphere will condense onto the surface as frost. Pluto's largest moon, Charon, is half the size of Pluto itself, making them almost a double planet system. Charon is tidally locked to Pluto, meaning the same face always points towards the dwarf planet. From Pluto's surface, Charon would appear to hang motionless in the sky, never rising or setting. Charon has its own mysteries. Its north pole is covered with a reddish material called tholins, complex organic compounds created when methane and nitrogen from Pluto's escaping atmosphere are modified by solar radiation. We're looking at organic chemistry happening in one of the coldest environments in the solar system. The Pluto-Charon system is unique in our solar system. While most moons orbit much smaller compared to their parent planets, Charon is so large relative to Pluto that they orbit around a point in space between them called the barycenter. They're locked in a gravitational dance forever, showing the same faces to each other, rotating every 6.4 days. Here's something that is gonna blow your mind. Pluto was discovered in 1930, but it hasn't completed even half of an orbit around the Sun since then. Pluto's year lasts 248 Earth years. It won't return to the same position where Clyde Tombaugh first spotted it until 2178. This means that every season on Pluto lasts about 62 Earth years. The spring that began in Pluto's southern hemisphere around 1987 is still continuing. By the time winter arrives, humans might have established permanent bases throughout the solar system. But perhaps the strangest object New Horizons encountered was Arrokoth, originally nicknamed Ultima Thule. This object looks like two pancakes stuck together, and it represents something extraordinary, a completely pristine remnant from the solar system formation. Arrokoth formed through a process called gentle accretion. Instead of violent collisions smashing objects together, these two lobes simply drifted towards each other at a walking speed and stuck together like cosmic snowflakes. The fact that this delicate structure survived for 4.6 billion years tells us that the solar system has been remarkably peaceful compared to the chaotic earlier days closer to the Sun. The Kuiper Belt contains hundreds of thousands of objects larger than 100 kilometers across, and probably millions of smaller ones. Some have highly elliptical orbits that bring them closer to the Sun than Neptune before swinging them back out to incredible distances. Others have tilted orbits that carry them far above and below the plane where the planets orbit. Some Kuiper Belt objects have their own moons. Some are binary systems where two objects orbit around each other. Some are contact binaries like Arrokoth. The diversity is staggering, representing different formation processes and evolutionary histories preserved in the deep freeze of the outer solar system. But even the Kuiper Belt has an edge. Beyond about 50 astronomical units from the Sun, 50 times Earth's distance from the Sun, objects become increasingly rare and the orbits more erratic. We're entering a transitional zone where the Sun's gravity still dominates, but barely. Here, the influence of passing stars becomes significant. Objects can be nudged into unstable orbits that either send them careening toward the inner solar system as comets, or eject them entirely into interstellar space. Here's a question that keeps astronomers up at night. What if we were wrong about life needing liquid in outer water and warm temperatures? Some of these Kuiper Belt objects might have subsurface oceans kept by liquid by radioactive decay, similar to what we see on Saturn's moons Enceladus. There could be entire ecosystems out there that we've never even imagined. Life forms that use completely different chemistry, that thrive in conditions we consider impossible. The universe has already surprised us so many times. Why not here too? We're about to leave the Kuiper Belt behind and enter a region so vast and sparsely populated that it challenges our understanding of what it means to be part of our solar system. We're heading out toward a theoretical shell of icy objects that extends perhaps halfway to the nearest star, a region where the sun's gravity is so weak that individual molecules in passing interstellar clouds can influence the orbits of entire worlds. This is the Oort Cloud, and it's about to show us just how far our sun's influence truly reaches. We've entered a realm that exists more in theory than observation. This is the Oort Cloud, a spherical shell of icy bodies that surrounds our entire solar system like a cosmic bubble. No telescope has ever directly observed it. No spacecraft will reach it for tens of thousands of years. Yet we know it exists because of the visitors it occasionally sends our way. To understand the scale we're talking about, imagine the solar system you know, from the Sun out to Neptune, as the size of a quarter. On that scale, the Oort Cloud would extend from here to about 300 meters away, in every direction. It's not a flat disk like the Kuiper Belt, it's a three-dimensional shell surrounding us completely. The Oort Cloud likely begins 2,000 astronomical units from the Sun and extends perhaps even to 100,000 AUs, halfway to the nearest star Proxima Centauri. At these distances, the Sun appears as just another star, no brighter than Venus appears to us on Earth. This vast region might contain 1 trillion of icy objects, representing several Earth masses worth of material spread incredibly thin across an almost unimaginable volume. Most Oort Cloud objects are probably just a few kilometers across, dirty snowballs of water ice mixed with frozen methane, ammonia and carbon dioxide, preserved at temperatures only a few degrees above absolute zero. These objects take millions of years to complete a single orbit around the Sun. Some have orbital periods longer than the age of complex life on Earth. An Oort Cloud object that began its journey toward the Sun when the first animals appeared on Earth's oceans would just now be reaching its closest approach. Every so often, something disturbs the Oort Cloud. A passing star, the gravitational influence of the Milky Way's galactic tide, or a molecular cloud drifting through our neighborhood can nudge one of these ancient icebergs onto a trajectory towards the inner solar system. What happens next is one of the most spectacular shows in astronomy, the birth of a comet. Comet Halley-Bopp was one of the brightest comets of the 20th century, came from exactly this region. For 4.6 billion years, it had drifted the outer darkness, unchanged, since the solar system's formation. Then, sometime around 2000 BCE, when the pyramids of Egypt were being built, gravitational forces nudged it toward the inner solar system. As Halley-Bopp approached the Sun, something magical happened. The pristine ice that had never felt the sun's warmth began to vaporize. Solar wind, charged particles streaming from the sun, pushed the vaporized material into two spectacular trails. One of dust, curved and yellowish, and following the comet's orbital path. Another of ionized gas, straight and blue, pointing directly away from the sun. When Hale-Bopp reached its closest approach to the sun in 1997, it was visible to the naked eye for 18 months, longer than any comet in recorded history. Millions of people looked up and saw a visitor from the very edge of our solar system, a messenger carrying ice that predated complex life on Earth. Long-period comets like Hale-Bopp reveal that Oort Cloud's existence through the orbital characteristics. Unlike Kuiper Belt objects that orbit the near elliptic plane where the planets lie, Oort Cloud comets can approach from any direction, above, below, or sideways relative to the solar system's main disk. The Oort Cloud is not just the edge of our solar system, it's the edge of our story, at least for now. Beyond it lies interstellar space, where our sun's influence finally gives way to the gravity of other stars. Out there, the boundary is blur. There is no up or down, no center, no edges, only the endlessness, expanding universe. But here's a twist. Even at this impossible distance, when we look back, our home still shines. That faint spark you can barely see, that's Earth. Every laugh, every heartbreak, every work of art, every revolution, every question ever asked, it's all happening there. Carl Sagan once wrote that astronomy is a humbling and character-building experience. And he was right, because the farther we travel, the more clearly see that our survival, our meaning, our beauty, all depend on that fragile dot of light. The journey outward is thrilling. The return inward is grounding. We pass Saturn's impossible rings, the moon's preserved footprints, the skin of Earth's atmosphere. And then, finally, we arrive back home. Look again around you. What once seemed ordinary is now extraordinary. That sky above your head is not just blue. It's the first layer of an ocean that protects all life. The ground beneath you is not just dirt. It's the surface of a world improbably alive in an endless sea of silence. The edge of everything is not the end of the journey. It's the beginning of understanding that wherever we go, however far we travel, home is the rarest thing in the cosmos. Thank you for watching.